Logarithmic Equations, Part 3. So what you see on the screen here, the little blurb, explains the new way of, or maybe the new type of logarithm, lnx. So just imagine for a moment that if you were to write a logarithm to base e of x, you don't really see that anywhere. You will make the connection that whenever your logarithm has a base e, it is called as natural logarithm. So this is the word natural logarithm. So now you have knowledge of two types of logarithm description, log to base of x or ln of x. So let's go to attempt to solve this equation right here. So first thing, you should realize that I have right here a rational expression. So part A divided is part B, and this is equal to part C. So whenever you come across a rational expression, usually we try to eliminate the denominator, and this can be obtained by multiplying both sides by ln x minus 2. Of course, this is for all values of x where ln natural logarithm of x minus 2 is not equal to 0. That is very important. So let's eliminate the fractions. So ln x plus 2 outside squared is equal to 2 times natural logarithm of x minus 2. So the next step will be to use the power rule in reverse, so that factor 2 will become exponent of x minus 2. So the left side remains unchanged for now. So the power of 2 equals natural logarithm x minus 2 squared. So if you remember the previous parts, we were saying that once I have logarithm the same base that is equated with another logarithm of the same base, then if these two logarithms are to be equal, that implies that that value inside x must be equal to the other value y. So this is something important to be aware of. So using that logic, we can now declare that x plus 2 squared must be equal to x minus 2 squared, because both logarithms have identical base. So we drop the logarithm symbol. We have to now solve this quadratic equation. So let us expand the left side. So x squared plus 2 times x times 2. So that's the binomial expansion plus 2 squared equals x squared minus 2 times x plus negative 2 squared, which is 4. Now we can observe the following. Like terms, identical on opposite sides, cancel each other out. So this is x squared is gone. 4 is gone. So what we have left is 4x is equal to negative 4x. Bring over to one side both terms, so you have 4x plus 4x, so 8x is equal to 0, which means that x must be 0. Now, we need to verify if this is a valid solution to that equation. So quickly, let's review the domain. The domain of the top portion, x plus 2 greater than 0, hence x is greater than negative 2. For the lower portion and the logarithm at the bottom, x minus 2 should be greater than 0. So that implies that x needs to be greater than 2. So on the number line, when we combine negative 2 to the right, so this is the number line, the positive 2, so the overlap takes place when x's are greater than 2. However, our root, x is equal to 0, is located outside of that domain interval. Therefore, this is not a solution, so you have to reject. So this equation, logarithmic equation, seemingly had one root, but upon the inspection, we are now certain about that fact that this is not a solution to this equation. So this is very important. Many times you may have one or two solutions because solving quadratic equation may lead you to that, but you have to always verify to make sure whether this number that you find makes sense in terms of the domain of logarithmic equation. Thank you very much for watching this video, and I'll see you next time.